This video is going to be about the force on a current carrying wire. So we've been talking about different magnetic forces, and we looked at the force on a moving charged particle. But if an electric current is just moving charges, then there should be a force on those just as well. And there is. So let's see, when we have a charge like this that's moving through a region where there's a magnetic field, then we end up with a force on this thing, and we use our right hand rule and we find that we get a force that comes out of the screen. There are a couple things we can do with this. One, we said our force was going to be equal to QVB, and for right now I'm just going to leave it at perpendicular, that things are already perpendicular, just to make it a little bit easier to see this. So Q, that's charge that has units of coulombs. V has charge of meters per second. B has units of Tesla, and altogether that's going to give me newtons. But what if instead I did a meters, a Tesla, and a coulomb per second? That could work too. So meters, that sounds like a length. Coulomb per second. Coulomb per second is an amp, so that sounds like a current. And then B field is still this. So there might be a separate force this way, and there is. If I have a wire like this, and I have charges moving to the right, and maybe this wire has a length of L, then if this is moving through a region of magnetic field, remember we defined the current as the direction of motion of positive charges. We can actually use the same exact right hand rule, and we're going to get a force that comes out of the screen. So what does this mean? We had a right hand rule we were using that looked like this. We had something like this, and we said our fingers are going to be the B field. The force was going to come right out of the palm of your hand. And then your thumb was going to be the direction of motion of the charge for a positive charge. Instead now, we're going to replace the thumb with the direction of motion of positive charge, as in a current. Now to make this formula a little bit more complete, we're going to have to do something like back here, how we said there was a perpendicular component. There's going to be a perpendicular component here too. So our magnetic force magnitude is going to be ILB perpendicular, or if you like, ILB times the sine of the angle between the current and the B field. That's it, really. I'll give you a separate video with an example or two.